So in this example, we're going to be looking at and probabilities, and the things to remember are A, that we have this awesome formula sitting in front of us, but B, it only works if our things are independent. That is, one outcome doesn't influence the next, one trial doesn't influence the outcome of the second, and so forth. Now, our first example is going to be looking at Loyola's retention rate for their freshman students, and what this refers to is what percentage of Loyola students come back their sophomore year. At Loyola, the retention rate is 86%, which means at the end of the freshman year, 86% of freshmen come back, 14% don't return for their sophomore year. We're going to start out pretty straightforward, and we're going to do that by looking at what if we have a group of 2 freshmen. Now, if we have 2 freshmen, we want to know right off the bat, what are the chances that both of them return? That is, given 2 freshmen, the chances the first returns and the second returns. That word "and" is really important because that tells me I want to use this formula. Now, we're assuming that these 2 freshmen are just randomly chosen freshmen. There's no association. One doesn't influence the next, which means I can use this formula for it. So if I want the probability that my first freshman returns and my second freshman returns, I can split that up into the probability 1 returns times the probability the second returns, which I know the probability a student returns is 86%. So this will be 0.86 times 0.86, which will give me the overall probability, if I take 2 random freshmen, that they both return to Loyola.